Okay, we've got a rather fine question that requires us to find various points and then finally find a volume of revolution when we rotate. But first I think we've got some points, and let's just figure out what we've got here. We've got a curve, y squared equals 5x. We've got the line, we've got this point. Our first task is to find a value of a. So what we have is we have point AA, and this is on y squared equals 5x, which must mean that a squared, putting x and y as AA, that must be true. And so a squared minus 5a equals 0, which means that a could be 0, which would give me this point, which I know it's not, or a could be 5, which of course it is. So we have the point 5, 5. Line L intersects at B, and we have a gradient for L and we have a point, and if we've got a gradient and a point for line L, then what we can do is simply write its equation. Standard equation of a line, given a point, given a gradient, and in it goes. So 5, 5 is the point. Gradient minus 5 over 7. And I could tidy this up, but I'm not going to. I will if I need it later, but I'm just going to leave the equation of the line like that for the moment. To find B, at B, the one thing I know about B at the moment is that the y-coordinate is 0. And if I put that in here, y-coordinate 0 is going to tell me that minus 5 is that. And let me sort this out. Multiply both sides by 7 and multiply out the bracket. That gives me 12. So that's 12, 0. Okay. Next thing I need to do is I need to rotate all this around the axes. Let me just shrink that down, give myself a little bit of room. Now if I start rotating things, let me have a look at this. If I rotate this section here, I think if I rotate that, what I will get is I will get a cone. Now, a volume of revolution I can get by integration, and it's always integral of pi y squared dx. Now that's going to be easy for this one because I've got my y squared. This one I could get my y out of here. I could square it up, I could integrate it, I could put my values in, but given that I can see this is going to rotate to give me a nice cone shape, and I know the volume of a cone, I'm going to do it as a volume of revolution by integration here, and then I'm going to do the cone there, I'm going to add them. Okay, so first of all, for this bit here, the volume, the integral between 0 and 5 of pi, now y squared is easy, that's just 5x dx, and 5 pi is just a multiplier, it's going to sit there. Integrate x to become x squared over 2 between 0 and 5, put my limits in, put 5 in, put 0 in. When I put 0 in, I'll clearly get 0 out. 5 squared, 25 times 5, so 125 pi over 2, and that's my volume for this bit. And the cone, well, volume of a cone, like any pyramid, base area times height and a third. Not a particularly fine rendering of a cone there, but you get the picture. And the volume of that is a third base area times height, 1/3 pi. Base I know from AA is 5, and height I know is 5 to 12, I know it's 7. So 175 pi over 3 is that, and total volume then, what I've got to do is put these together and hope I don't run out of room. 125 over 2 pi plus 175 over 3 pi. Put them all over 6. And my grand total, which I shall squeeze in down here, looks to be 725 over 6 multiplied by pi, and there's my final volume done.